Sorry about that.
Okay.
Okay, maybe we can just look at dynamic programming.
Okay.
Well, before we move into that, any questions?
Nope. So good so far.
Okay. Okay, of course. Dynamic programming. One more thing. Let me. Okay. I've made mentions of. I've not told you the applications of breadth first search and depth first search, right? Good. Like for example, when you are using, remember, when we did graph, we actually said that the applications can be seen for a graph, that the application could be seen in an app like Google Map. You remember? Good. Like social media accounts where you post a comment, somebody comments under, another person comments under that comment. It could spread in whichever direction.
Right.
It may not be exactly one way, but basically you have a particular comment that you now have responses to those comments and all that. Okay, so that means that they are all like linked together. And remember, we talked about for social media account platforms like Facebook, where you need to connect to your friend, and your friend has another friend that he is connected to. And by that means, any of those platforms could make recommendation. Okay, like for example, Facebook is too good at that. Okay, friend's suggestion that this friend of your friend could possibly know you, and you could possibly know him or her too.
Right.
All right. So that's just like exactly what it's all about. And when you now look at the depth first search, remember, breadth first search look out for its neighbors before it moves down. So using that concept, you can be able to use it to find the shortest route, for example, in Google Maps, between two different points. Yeah. Okay. Then for depth first search, you can use it like in a graph to check out if a particular value item node actually exists. But aside that, you can actually use it to check, okay, are they really, really connected and all that? Like, you remember when we looked at graph, we looked at different types of graph. We look at cyclic graphs. Can you start from one point, and after you've done your transversal, can you come back to that exact point?
Right.
Okay, so that's what depth first search could be used for. Then on the other hand, you actually use what is it called? Breadth first search in distribution of network flows. Okay, so that you'd be able to know exactly how you can be able to distribute your network. Like I just talked about social media accounts, they call it peer-to-peer network. Okay, like you are connected to your friend and your friend is connected to another friend, just like that. So it could, at the end of the day, in the network of all this connection, you could now, maybe you are not directly a friend, you are not a friend to the friend of your friend, but another friend of that, of your friend's friend is your friend.
Right.
Okay, good. So it's just in all those ways you could get connected in so many undescribable ways and all that. So that's just exactly the way it is. But remember, the disadvantage of breadth first search is it consumes more memory. Okay,
Gotcha.
good. But it can be faster because it does not use recursion. Although you can actually represent it in a recursive way, but due to the operational cost of recursion, which you and I know that it makes code implementation not to be that efficient.
Right.
And another thing is because of hitting a dead end and backtracking, depth first search could be slower. Okay, so that's just it.
Gotcha.
Yeah. Okay. I hope you can see my VS Code, right?
Yep.
Okay. Okay. You've heard of Fibonacci number, right?
Yes. I've heard of it, but I'm not sure what it is though.
Okay, it's all about if you have, let's say, different numbers. Usually it used to be like, or it is like 1, another 1, 1. Now the concept is, for example, if these numbers, if these numbers are items in an array, okay? If you now add the first item to the second item, you get the next item. If you now add this and this, you get this, you get 2, okay? If you now add 1 and 2, you get 3. So it continues. 3 and 5, you get 3 and 2, sorry, will give you 5. 3 and 5 will give you 8. Okay, 8 plus 5 will now give you 13. 8 plus 13 will give you 21. So it continues and it continues indefinitely.
Okay.
Okay, until it hits what's it called? Infinity.
Okay.
Okay, but basically, how can this be represented? It can be represented using recursion. But the question now is, recursion has an effective cost. So how can this be done in order that we can be able to get an efficient code running? That is what dynamic programming is all about.
Okay.
Now, for example, I remember those days growing up, due to the nature of academic system here in Nigeria, there are some exams that you will write, you will not be able to use any calculator at all.
Right.
Okay, we call it JAMB. That's when you want to, it's called Joint Admission and Matriculation Board Exam. Okay, when you want to gain admission to study in any of the higher institutions in Nigeria, you have to take this exam. And in this exam, basically everybody will write not less than, everybody will write 4 subjects, okay? And each exam, each question, each subject will have 60 questions. And each of those 60 questions, you are required to spend 45 seconds, sorry, to answer a particular question, okay? And if the subject that you're writing has some calculations in it, calculators are not allowed to be used in this exam.
Right.
So you have to do everything with your brain,
Gotcha.
unaided. But that's to the extreme, right?
Right.
Good. Now there's also a level in Nigeria when you want to write secondary school, high school, right? I think it's high school that you call it.
Yeah.
In Nigeria, sorry, let me talk a little about our educational system. We
Okay.
spend what we refer to as 664 educational system. That this first 6 represents 6 years in primary school. Then this second 6 represents 6 years in secondary school or in high school. Then this third number, which is 4, represents 4 years minimum in the university or in higher institution.
Right.
All right. Some courses like pharmacy are 5 years. Law is 5 years. Then some other courses like dental surgery is 6 years. Then MBBS, that's a bachelor in medicine and bachelor in surgery, is actually 6 years. But most of other courses are 4 years. Now
that's the same as ours, by the way.
Okay. In between this second 6 years is divided into three. The first 3 is for junior high school or for junior secondary school, and the second 3 years is for senior high or senior secondary school. Now, by the end of these 3 years, you're expected to write exams. Here, we call it Junior WAEC. That's West African Examination Council. And here you write Senior WAEC, okay? Now let's erase this one because it's not our object of focus. Here, you are not required to use sophisticated calculator like scientific calculator. You can use a calculator like all those calculators that only have numbers and memory. Then, and the mathematical operations like multiply, add, subtract, those are the basic calculator. Let me just check if I can see anything of such in Chrome.
Okay.
Yeah. Non-scientific calculator. Oops. Okay, good. You see this particular calculator? Good. So you only have your maths operation and this whatever are used to store. For example, you did some mathematical operations and you don't want to wipe it from this calculator. You just hit this M+, you add it to the memory. Okay. Good. So why I'm trying to let you know about this is that's exactly the same way dynamic programming works. You try to hold on to a particular value so as you will not be able to, so that it will help you not to go and review that particular operation that you've done before, but you can easily recall it and use the answer. And in so doing, you'll be able to spare some more time and make your codes to be efficient.
Okay.
Now let's go back to our this. I think there's recursion somewhere. Let me check.
Okay.
Recursion, yep, dynamic programming. Now, these are okay. Yeah, they've even written the Fibonacci recursive function here. Let's say that we want to get the Fibonacci number of 5. Let's see it run. Yeah, this is very good for us. Are you seeing something?
Yep, I'm seeing it.
Okay, good. Now, this actually is a demonstration of the expensive cost of recursion. Now, we pass 5 as a value. Okay. Here it calls 5 minus 1, which is 4, right?
Right.
And it calls on 5 minus 2, which is 3, right here. Okay. It calls itself again. 4 minus 1, it gives 3, right? 4 minus 2, just in that order.
Right.
You now notice that here, first of all, here, 1, 2, 3. Repetition of the same thing. Is that correct?
Yep.
Good. Then this and this is exactly repetition of another thing. Yeah. Then this. Sorry, I just got the message. And before you know what is happening, anyway, the repetition starts with 1. You have 1, 2, 3, 4, 5, 6, 7, 8. So by the time you do these 8 different operations, you now do these 3 different operations, execute these 2, this and this. How many? Let's count. 1, 8, 11, 13, 14, 15 different operations. Now let's see what happens. Let's increase this to 50.
Okay. Not too
many. Actually increasing the speed, but I'm not sure it's okay. It says too many vertices. Let's say, okay, maybe like 20. Oh, still too many. Because the operation will be too expensive. Okay,
gotcha.
This is for 10. This is for 10. Just watch exactly what is happening. Remember the what's it called? The speed is so much.
Right.
Yes. We increase the speed so that we will not spend so much time. Yeah. But while you are watching it, let me just reply a message, please.
Yeah, sure, no problem.
Okay, so you can now see how costly recursive functions are.
Yeah, it's still going.
So it continues. Now the question is, in as much as recursion is this expensive, does it mean that we are going to throw recursion away?
Nope.
Okay, but the question now is, what are we going to do in order to avoid these repetitions of all these operations and make them to be efficient or effective for our own use? Now, that is okay.
I was just gonna say, I assume that if you didn't do it recursively, if it was longer than it would take for recursive, maybe you would use this instead.
Maybe you will use,
like, because maybe there's some instances where this is faster.
sure, there is. Okay. Okay, I wanted to do something. I'll copy this code here. I hope you can see it very well.
Yep.
Okay, do me a favor, copy it, run it on your system. Let's see how long it's going to take.
Okay.
Run, call this function, okay?
Okay.
Call it with a value of 5, call it with a value of 10, call it with a value of 50.
Okay.
Let's see like how long it's going to take you. Okay, please, first of all, what's the RAM size of your system?
For RAM,
Yep.
let's see. 16 gigs.
Okay, that's fair enough. I use 12 gigs, so just try it. Let's see how long it's going to take. I know for that of 50, it's going to take your system quite some time for you to finish running it.
Right.
Good.
Okay. Let me see.
But to avoid that time, maybe just, okay, you can still go ahead. Excuse me, you can still go ahead and do 50.
Okay, you want me to do it right now?
Yes, go ahead.
Okay.
I will copy the same code and place it on my, what is it called?
Oh, you want to put it in the chat?
Yes, I will.
Okay.
Oh, okay, hold on. Okay, these are, let me send it first.
Okay.
This is just the, what's it called? You can now see function, the name of the function maybe you call it feed and pass n as your parameter.
Okay.
Then don't forget to close this curly brace. Yeah. Oh, sorry, the name of the function is f. I labeled it fib.
Okay, no worries. I changed it to fib.
Don't forget.
So when I did it with 5, it took 0.88 seconds.
Okay.
And then I just did it with 50 right now, and it's still running.
So it will continue to run, and all that, and the rest of them, and the rest of them. So
Okay.
the question now is, what are we going to do so as to make this recursive function something that could be able to solve our problem within a very short while? Okay, good. So this was the essence why I brought up that issue of the calculator, where you'll be able to do a particular operation, like let's say that you have a mathematical operation like this. Let's say like 20 multiplied by 5 divided by, let's say, 2 minus 7 plus 49. Okay. Of course, you know that there are rules guiding this kind of stuff. Okay. You start with division. Is that correct? Using what we call BODMAS. You do brackets. Okay, all of them are enclosed in a bracket. Off, there's no off. Division, you first of all do this. Okay.
Okay.
Then multiplication, you now whatsoever you get as the answer from here, you now multiply this. Okay. Addition, you now add this to this. Then subtraction, whatever you have from this. Oh, sorry. Whatever thing you have from this operation, you now subtract whatsoever thing you have from this, from it. So what do you actually do? If you start doing this divide by this, 2.5, you keep it aside. 2.5 times 20, you now have 50, you keep it aside. You now say 7 plus 49, which will give you 56, you keep it aside. You now say whatsoever thing you have from this, subtract 56 from it. It's going to take you so much time, right? So what you quickly do is, once you get this value, you store it in memory. Once you get this other value, you store it in memory. Once you get this other value, you store it in memory. You just subtract whatever thing you have on your memory. You subtract this from whatever thing you have on your memory. Right. So you now find out that storing it in memory has given you an advantage of speed and lessening your burden. Good. So that is where something that is called optimization comes in dynamic programming.
Okay.
It is all about, let's go back to Chrome. You've seen the different operations that we can do. All right. Let's move back to a smaller number so that we can have more space. Now, we've seen some repetition of, or what's it called? Some repetition of operation that we can do in this recursive function. So what we'll do is, once we get our base case, which is 1 or 0, depending, okay? We store it in memory. And in computer science, it's called caching.
Gotcha.
Okay. Okay. Another way to put it is, when you visit a particular website, all right, the builders of the website or the developers of the website, they usually have cookies, so that the next time that you are visiting that website, it won't start loading all those files that particular page has, because it has already stored cookies in the memory, so that once you visit that particular page, it calls it up from your memory and it helps it to load faster the subsequent times that you are visiting it compared to the first time that you're visiting it. So what you now do at this base case, since you have this base case here, okay, which one should be the first? This should be the first, all right? You store this in memory, all right? You store these two in memory. Now, what will happen is once you get to it recalls it, because already all these ones have been stored in memory. So what you need to, by the time it's getting here to call 2, it picks up 2 from this. Okay, by the time it's getting here to call 3 to do all these operations, because 3, the operation calling or invoking the function calling 3 or passing it as a parameter will now call it up from this memory where it has already been stored. So instead of doing all these operations, it only makes reference to it. It picks it from where it has been stored from memory. All right. And 4 will call 2, but because 2 is already here, picks it. And you now notice this will be called faster. So let's move back to VS Code. Let's see if there's a way that we can do some kind of optimization to this. Okay. Has the parameter, when you pass 50, has it finished running?
Let's see. Yep. It took 210 seconds. So almost 4 minutes.
So let me pick back this function. Okay, there's no, what you do in order to optimize this function, do you remember our hash table?
Yep.
You remember that it maps out a particular key to a value.
Right.
Okay, and in JavaScript, hash table is just an object.
Right.
Okay, let's say you're passing an empty object here.
Okay.
But remember, we can equally do it here. Is that correct?
Yeah.
Okay. But let's pass it at the topmost level. Maybe we'll just say, we'll just use hash.
Okay.
Or hash map or hash table, whichever one.
Okay.
So the first thing that we are going to do is we will still follow the rules of recursion, which are a recursive function must have a base case. Is that correct?
Right.
And it will have a conditional statement. Okay, the base case is the conditional statement, actually. And it will have a second, what is it called? Second line of operation where you do the evaluation of your value. Okay. So we can now say for this n, this number, remember here, they now represent different numbers: 1, 0, 2, 3, 4, and 5. Okay. For all these, for these numbers, all right, if it is in a hash map, all right, just return hash map and pass this as a value to it.
Okay.
Now, when we get this, map the value and store it. Remember, when you use a bracket notation to access an object, it simply means dynamic, that this is dynamic. Because if we use this,
Right.
okay, if we use this, it will be overwritten.
Mm-hmm.
Okay. So once we have this as the base case, the next other thing that we are going to do is this return value that we have, we move it away. We will still return something, okay?
Mm-hmm.
But in this line of code where we ought to do our operation, like in this case, like here, okay? We'll just go back and see that our hash map, okay,
Mm-hmm.
of this value will now be equal to this. But remember, our fit function has two parameters. Is that correct?
Right.
And this second parameter, remember, is empty.
Right.
Just pass this parameter here.
Okay.
And just pass this parameter here too. So when you call this function, the same thing that is doing here when it hits the base case.
Mm-hmm.
So you are storing whatsoever value of this number, of this and this, whatsoever the sum is going to give to you, you store it as this.
Gotcha.
All right. So at the end of the day, what you just do is you just return this. Let's see whether is going to, is it fast?
Oh, is that it already? Yes. Very fast. I thought it was an error.
Okay, let's check it out again.
Yeah.
Remember, okay, the first time I called all these numbers, he had for 5, for 10, and for this particular number for 50. Okay.
Mm-hmm.
Let me call all of them again.
Okay. Wow. Yeah, that's super quick.
So that's how you optimize your code so that you don't actually waste so much time waiting for the value you want to be returned.
Got it.
Yes. So in simple terms, okay, in very simple terms, dynamic programming is all about getting a particular value, storing it for future reference, so that when you need it, instead of struggling and wasting your energy and time repeating that particular operation, you only go to that particular place you stored it, pick it up, make use of it.
Right.
Yeah. So actually, there are two basic ways to do optimization of code. You either do it this way. This is called memoization. I hope I get the spelling correct. Memoization.
Okay.
And there's tabulation and memoization. Those are the basic ways you can optimize your code for you to make them to be really, really dynamic. Remember, this is a way that you can be able to make your code to be dynamic using an object in JavaScript.
Gotcha.
Yeah. So
well, good.
That is that.
Awesome. Shall we stop it there? That's
okay.
Good.
That's good. I was able to check out some questions in binary search platform.
Okay.
What I will do is I'll send the questions to you so that you can look them up. And I don't know how your time will be. Maybe let's see. Today is Wednesday, right?
Yep.
Okay. Let's meet on Monday so that let's see what you've done.
Okay.
Will that be good?
Yep, that'll work.
Because with this, I think that we've done the basic things that need to be covered in data
Okay.
structures and algorithm. Although it's not possible for us to cover everything. Like I know we did not do binary heap like max
Mhm.
heap or main heap, but
Right.
except if you're interested that we should do it, we can look at it. Then I know that there are different types of categorization of algorithm, but basically we've covered them. We've looked
Yeah.
at divide and conquer method, when we looked at merge sort and quick sort.
Mhm.
Okay. Today we've looked at dynamic programming. Okay.
Yeah.
We've actually looked like, okay, we've not looked at greedy algorithm, but
Mhm.
okay, you'll be running out, right?
You said I'll be running? Oh, well, I'll be leaving?
Yes, you'll be leaving, right?
No, I'm good. I'm good right now.
Okay.
Mhm.
Okay. Some persons will now categorize like greedy algorithm,
Mhm.
dynamic programming, backtracking. Okay, what is backtracking? Backtracking is simply when you don't actually know exactly what to do. You try this method, is it going to work? It doesn't work. You come back, you try another method, it doesn't work. That's just what
Okay.
backtracking it's all about. Like I told you about greedy algorithm.
Mhm.
Okay, maybe we'll just look at greedy algorithm
Okay.
with some explanations.
Okay.
The crazy thing about it is all your life you've been using greedy algorithm.
Mhm. Eating?
All your life you've been using greedy algorithm.
Mhm.
Okay, human beings are meant to be greedy. Is that not true?
Yep, they are.
Human beings on the average, we are greedy.
Right.
But that's not what greedy algorithm portrays.
Right.
Greedy algorithm simply means when you have different solutions to tackle a particular problem, okay, you now, after you have checked out all those solutions, you now pick up the most optimal or the best solution or the most efficient solution suited for that particular problem. I'll give you an example.
Mhm.
Okay, let me ask you this question. What kind of laptop do you use?
A MacBook.
Why do you use MacBook?
Because it's faster.
Okay, that's one.
Mhm.
Any other reason?
I would say it's compatible
Okay,
with other things. Easier.
okay. I believe when you wanted to buy this particular MacBook that you are using,
Mhm.
you are aware that MacBook was not the only operating system that exists in the
Right.
computer world.
Mhm.
You know about Linux.
Yep.
You know about Ubuntu.
Yep.
You know about Windows.
Absolutely.
So why, of all these available choices, why did you go for MacBook? Because you had an intention in mind.
Right.
Okay. We are looking for a particular solution best suited for your need. It's
Mhm.
not that on the average that you cannot get a Windows system that can do what ordinary PCs can do,
Right.
the same is applicable to Ubuntu and Linux.
Mhm.
But you now look at it, MacBook has a particular age over these other operating systems.
Right.
So that's ability for you to be able to, number one, determine your need, and of all these numerous solutions available to help you tackle the problem you have at hand, you went for the best, efficient, or the most suitable solution to your problem. That's exactly what greedy algorithm is all about.
Okay.
I'll give you another instance. You're a medical doctor, okay?
Mhm.
And you have your own hospital.
Mhm.
Let's say, what kind of medical condition I'm going to give now? Okay, you are the best in town when it comes to surgery, okay?
Okay.
But unfortunately, on this particular day, you traveled out of town because on the immediate, no life-threatening condition, none of your patients has any life-threatening condition in the hospital.
Mhm.
You only traveled out of town, perhaps to attend a medical conference, or you were invited, okay, you were invited as a facilitator, as a speaker to present a paper. So you actually looked at it, knowing the importance it has to your medical practice. You
Mhm.
chose to honor the invitation. And while you were there presenting your paper, you have about, let's say, 15 more minutes to go. You
Mhm.
receive a message that you have a patient who has a life-threatening condition and he needs medical attention between that moment that you are receiving the message and the next 2.5 hours.
Mhm.
Okay, note that time frame or time limit. And you have just about 15 minutes to round up with your presentation and leave.
Mhm.
Now, remember, you are out of town, you're in another town, and you need to go back to your base town. And you have different means of transportation. And since you have actually taken the oath to do everything possible within your means to preserve the life of your patients, so you now have a duty to fulfill to move back to your base city as quickly as possible. Now, you and I know that there are different means of transportation. You have sea, you have air, you have land. And when you talk about land, you can make use of car, or you can make use of a train. Okay. Now, of all these means of transportations that are available, you know that you have limited time.
Right.
Okay. If you fly from where you are, from the town where you are to your base town, you'll be able to make it, let's say, within 45 minutes. Okay, let's say 1 hour, you'll be able to make it to the hospital within 1 hour. If you take train, you'll be able to make it to the hospital, let's say, in the next 1 hour and 30 minutes. If you go by ship, let's say you will make it in the next 2 hours.
Gotcha.
But if you travel by car, perhaps you'll make it in the next 3 hours. Of all these means of transportation, which one will you instinctively choose?
The one that was the first with the hour. Was that air, did you say?
Yes.
Yep,
the air has the shortest time frame.
Yep, so the
Good.
shortest.
Good. So you now see also in this situation, there are solutions, but all these solutions may not be able to be the best.
Right.
for the situation or for the problem at hand. So
Mhm.
what do you do? Of all of them, you select them and choose the best out of
Right.
this. So that's basically what greedy algorithm it's all about.
Okay.
Yeah.
I see. So is it a matter of like, creating different algorithms and testing them?
Okay, let me give you an instance.
Mhm.
We looked at sorting algorithm. We looked
Mhm.
at bubble sort. We looked at insertion sort. We looked
Mhm.
at selection sort. We looked at quick sort. We looked at merge sort.
Mhm.
You remember?
Yep.
At the end of the day, all these sorting methods will give you exactly the same answer,
Right.
but they have their downsides. Some of them make use of more memory.
Mhm.
Is that correct?
That's correct.
Good. Some of them are slower, as in when it comes to worst case scenario. Let's quickly check them. Let's go back to Chrome.
Okay.
Yep. Now, for quick sort, worst case is terrible.
Right.
Same is applicable to bubble sort, same is applicable to insertion sort, same is applicable to selection sort.
Mhm.
But when you compare all this worst case scenario to merge sort, it's more efficient, right?
Right.
But all this, at the end of the day, will still give you exactly the same answer, but they are not efficient.
Right.
Good. So what do you do? Of all this, in as much as you get the same answer, but you go for the most efficient one, you will
Right.
now pick merge sort. You remember?
Mhm.
You remember the reason why I actually brought up a particular visualization, and I told you that in as much as insertion sort, the worst case scenario is this, but there was a place it performed better. Do you remember?
Yep, I remember that.
When you have a nearly sorted arrays.
Right. It was really
Good.
fast.
It was really fast. So it's going to be useless in as much as the worst case of merge sort is this. It's going to be useless or inefficient, not useless, inefficient for us
Mhm.
to use merge sort to sort a nearly sorted array.
Right.
So in that situation, in as much as merge sort at its worst case is pretty faster than all this, but in that particular scenario, merge sort is not going to be efficient. So
Right.
what do? We go for the most efficient one,
Right.
which is insertion sort.
Gotcha.
Good. So that's just like what greedy algorithm it's all about.
Okay.
Not like when you now notice, we've now looked at two scenarios or two instances where this can be applicable. On a normal, this has this and is
Right.
better than this.
Mhm.
So, but with this, you also know that there are situations or conditions which greedy algorithm may not be most suitable. You
Right.
may employ, let's say, dynamic programming. We just saw what happened, right?
Right.
When our recursive function was optimized, we saw how, we saw how quick it was.
Yeah.
So the issue of algorithm is basically, sometimes you'll notice that you'll be able to do exactly the same thing with different algorithms, but the best choice at that moment should be the most efficient one. Another one we can look at is, you remember this, our breadth first search and depth
Yeah.
first search.
Yeah.
You remember they actually gave us exactly, both of them visited all the nodes of SXs and they gave us the same exact answers, right?
Right.
Okay. But in this case, all of them are not going to give us exactly the same thing.
Yeah.
Oh, sorry, there should be 4 here. I'm seeing 3. That's what I'm looking for. We did post order, in order, pre-order. 1, 2, 3. Then we did BFS. So what happened? Okay. Okay, 4.
Mm-hmm.
All right. I would have said. So both of them actually visited. Don't mind about the splitting of another post order, pre-order. Just visualize it as BFS and DFS.
Right.
Both of these methods actually visited all the nodes in the data structure. Is that correct?
Yep.
And printed them out.
Yep.
But we know that when we are looking for the shortest path, it's going to be inefficient to make use of DFS. Is that correct?
Right.
And when we are looking for the longest path, it's going to be inefficient to use DFS.
Right.
So that's like,
got it.
Like another example I can bring to the table of what like greedy algorithm could look like.
Gotcha.
But notice, in as much as we can do this, maybe we are just searching for a particular value. This is not going to be as efficient as our lookup.
Right.
Good. Because lookup should be at, what is it called? Lookup should be at O of 1.
Right.
That's that. Oh, O of n. Oops. Is at O of n, sorry.
Right.
So that's just like what they are all about. Though different persons have different means of what did they call it? They have really different means of categorizing algorithms.
Gotcha.
Well, I cannot be able to say authoritatively it's just exactly like this. Some persons may tell you 7, some persons may tell you 5, some persons may tell you 1 million, and I'm just exaggerating.
Right.
Some persons may tell you that there are more than 5, 6, and all that. Right. So that's just, I guess, that's just exactly we've come to the end, so to say.
Yeah.
Except if you still want us to do like 1 or 2 that we did not look at, but that is going to be based on your decision. Like I just made mention of this yes, heap. Okay, there's no heap here. No heap. Okay.
Yeah. So what I'm hoping is if we can so if we could just do problems and even if, you know, maybe if I could show up, like for instance, if you're like, hey, create a linked list, like basically where we just test everything, and so, but we can keep it going.
No problem. Like I said, I'm going to send you some titles of questions that you can look up on binary search.
Yeah.
Okay. Yes. So we can I need to attend to some things between now and weekend. maybe all things being equal and God's willing, we'll
Mhm.
meet on Monday. We look at it together.
Okay.
Okay, that was what I said earlier on. I cannot tell you, okay, that we are meeting tomorrow.
Yeah. No problem.
Okay, so with that, subsequently we can look at it. And another thing which can also be helpful, we can also do revision just as you've suggested, no problem.
Okay.
But by Monday, just look at these ones by Monday, okay?
Okay.
Let me know the next direction you want us to take.
Okay. Sounds good. All right. I appreciate it. Thank you very much. It's always an
welcome.
honor.
You're welcome.
All right. Well, talk to you later. Have a good night.
You too.
All right.
Good night.